So we know what rational functions are. Those are just functions expressed as a fraction, where you have a function in your numerator and a function for the denominator. So our very first step that we look for is, can we factor to simplify? Okay. Last class we only had one example where we factored. This class we're going to have more than just one. Okay. Not every single problem can be factored though, so just check. Once you do that, the restrictions on the domain is what we did last class also. You take the denominator, what can it not equal? So you set the denominator equal to 0. Figure out what that value is, because you can never divide by 0. So that's why we do those restrictions. Your x-intercepts and y-intercepts, that's new for this lesson that we didn't do last lesson. Okay, your x-intercept is where you set your numerator equal to 0. There are a few missing things in this statement. So if you get 0 equals a number, so if you get a false statement, then that's going to be no x-intercept. Okay, so if you're solving and you get a false statement, then that's going to be none. For your y-intercept, you're going to find the value of the function at x equals 0. So you're going to plug in 0 for x into the original equation and solve for y. Okay? I put original because some of these are going to be simplified, so just always go back to your original. Now remember that your restrictions on your domain tell you what your vertical asymptote is. Okay? Whatever it cannot equal is what your vertical asymptote is. Now remember that you cannot cross vertical asymptotes, but there are going to be situations that we look at this class that was not in last lesson, that sometimes your graph can cross the horizontal asymptote, but it can never cross the vertical asymptote. Okay? The same rules apply for finding your horizontal asymptote. These 3 key points, if your degree of the numerator is less than the degree of your denominator, then your horizontal asymptote is y equals 0. If the 2 degrees are equal, remember you take the coefficients of that leading degree term. So you take the ratio of the leading coefficients. If the numerator is greater than the denominator, then it's going to be none. You don't have a horizontal asymptote. Okay? Now, to check if the graph crosses at the horizontal asymptote, you're going to take whatever the horizontal asymptote number is. You get y equals something. You're going to take that number and set it equal to your original equation. And you're going to solve. If you get x equals the number, then that means that is the point where it crosses the horizontal asymptote. If you get a false statement, it does not cross. Okay? Then when you're done with that, you do your domain and range. Okay? This first example, I put down each thing that you should be looking for. The next ones I do not. Okay? So your first step is you're going to always try to see if you can factor it. Can you simplify 1 over x minus 3? No, you cannot. I can't do anything with that. Alright, restrictions on my domain. If my denominator is x minus 3, x cannot equal what? 3. So there's my restriction. If you still need to do x minus 3 cannot equal 0 to get your x cannot equal 3, then that's fine too. Okay? So your x-intercepts, we set our numerator equal to 0. Here our numerator is 1. Does 1 equal 0? No. 1 does not equal 0, so there's going to be no x-intercepts. Your y-intercept, you're doing x equals 0. So I'm going to have 1 over 0 minus 3, so that is negative 1/3. So my y-intercept as an ordered pair would be 0, negative 1/3. Okay? Your vertical asymptote is what your restriction on the domain is. So if x cannot equal 3, then that tells me my vertical asymptote is x equals 3. Y'all good so far? Okay. Now the horizontal asymptote, we're looking at the degree of the numerator and we're looking at the degree of the denominator. My numerator is just a constant, so that degree would be 0. My denominator is x, so that degree is 1. So my numerator is less than my denominator, so what's my horizontal asymptote? Y equals 0. Y'all good?
I have no idea about the degrees.
You're looking at the highest degree of your numerator, so if it's a constant, the degree of your numerator is 0. So if I had x squared plus 3x minus 4, that degree would be 2. That's your highest exponent. Now that makes sense?
Yeah.
Okay, so I had no variable, so my degree is 0. Here it's just an x, so that degree is 1, because that's your exponent. Okay? Alright, does the graph cross the horizontal asymptote? This is new. Okay, so what we're going to do, we're going to take our original function, 1 over x minus 3, and we're going to set it equal to the value of our horizontal asymptote. So we're going to set it equal to 0. Well, to solve that, I have to multiply both sides by the denominator for that to cancel. That leaves me with 1 equals 0 times anything is 0. Well, that's a false statement, so it does not cross the horizontal asymptote. Okay. Now, before I make the tables, I like to graph my asymptotes like I did last time. So I'm going to graph x equals 3. Remember, that's a dashed line. And then y equals 0. This graph, the axes are a little bit darker and bolded compared to your usual graphs. Just make sure I know that you're putting an asymptote there. Then I'm going to go to my calculator, go to my graph, and type in my original function, 1 over x minus 3. Go to my table. So last class I told you just needed enough to make sure you knew what the curve looked like. So I'm going to go a little bit further left into the negatives. So it all starts leveling out close to 0. If I keep going, I'm just going to get smaller decimals. So I'm going to do -2, -0.2 for my table. -1, -0.25, 0, -0.3, which that is your y-intercept that we already solved for. That's your 0, -1/3. Then you've got 1, -0.5, 2, -1. 3 should be undefined because that's your vertical asymptote. Now, I'm running out of space, so I am splitting this table. You certainly don't have to when you're doing it on your worksheet. If you have enough space to make it long, that's fine. So here, 4, 1, 5, 0.5, 6, 0.3, 7, 0.25. It's starting to level out again, so I'm going to stop there. You're all good with that? Okay. I'm going to plot my points. I didn't have very many points between, well, I could have changed the table step in my calculator if I wanted points between x equals 2 and x equals 3. But if you know what the curve looks like, that's not necessary. Okay, so once you graph it, we're going to talk about our domain and range. Your domain is going to go from negative infinity to what? Y'all remember? Your vertical asymptote is going to break this domain up. So it'll be 3, close parentheses, do your union, open the parentheses again, 3 to infinity. So whatever your horizontal asymptote is, that's what's going to break that domain. That is explaining it's all real numbers except x cannot equal 3. So my range is going to be negative infinity to whatever my horizontal asymptote is, which is 0, and it breaks at 0. Y'all good with that? So it is not hard. You just have a lot to keep up with. Okay? So example 2, I've got f of x equals 6 over x squared plus 1. My first step, we always check to see if we can factor. Can we factor that? No, it's even though it looks like you could factor it into x plus 1 and x minus 1, that's only whenever it's the difference of two squares. This is the sum of two squares. I cannot factor. Okay? So then I'm going to move on. My next step is to do my domain restrictions. Okay, I set my denominator x squared plus 1, that cannot equal 0. Alright, well if I were to solve for this, that would tell me x squared cannot equal negative 1. I would have to take the square root of both sides. What happens whenever you take the square root of a negative 1? It's just I. So this is telling me that x cannot equal an imaginary number. So because the only restriction is it cannot equal an imaginary number, that domain is all reals. So that's telling me there are no restrictions. Do y'all understand that? If your only restriction is referring to imaginary numbers, then there are going to be no restrictions on your graph because we're only dealing with real numbers. Okay? So then I'm going to look for my x-intercept, set my numerator equal to 0, so 6 equals 0. That's a false statement. So there are also no x-intercepts. Then I'm going to solve for my y-intercept. So that's where I do f of 0. So 6 over 0 squared plus 1. That is 6 over 1, which is just 6. So my y-intercept as an ordered pair is 0, 6. Y'all good? Okay. So then my vertical asymptote, if I don't have restrictions, do I have a vertical asymptote? No. But I'm still going to have a horizontal asymptote. Okay, so this is where you look at the exponents and the degrees of your numerator and denominator. So my degree of my numerator, it's just a constant, so that's going to be 0. The degree of my denominator, I have x squared, so that's the degree of 2. My numerator is less than my denominator, so my horizontal asymptote is what? Y equals 0. So then we check if it crosses the horizontal asymptote. So we're going to set our original function, 6 over x squared plus 1, equal to that horizontal asymptote value of 0. Well, what happens there? If I multiply x squared plus 1 by both sides, I end up getting 6 equals 0. Not true. So it does not cross. You can tell me doesn't cross. You can tell me, if you set it up as crosses horizontal asymptote with a question mark, you can tell me no. Okay? That's what I typically do. So then what I'm going to do is my only asymptote is y equals 0. I'm going to go ahead and graph that. And I'm going to plug the function into my calculator to build the table. So I'm going to doc B. So now my graph kind of looks like a bell curve. It doesn't look like what we're used to graphing. Still go to your table. Go as far negative as you think you need. Okay? I'm going to go from -3, 0.6, -2, 1.2, -1, 0, 6, which is the y-intercept we already solved. Then 1, 3, 2, 1.2, and 3.6. Y'all good? So here, my domain is what? Negative infinity to positive infinity, because I had no restrictions. My range is what? Does it go to positive infinity? It's 0 to 6. So my asymptote is 0. I'm not going any lower than that. My asymptote is 0 and my max point is 6. So the 0 has a parentheses. The 6, is that going to be a parentheses or a bracket? It's going to be a bracket because I actually have a point on that graph at 6. Y'all good with that? Y'all have any questions? Okay. So example 3. F of x equals x squared minus 2x minus 8 over x squared minus 9. Our first step, can you factor it? Yes. So our numerator is going to factor into x minus 4 times x plus 2. And our denominator is going to factor x plus 3 times x minus 3 because it's the difference of two squares. Then you would check, can you simplify? I can't simplify any of this. I cannot cross anything, any of the factors out. So that is just factored form. It's not going to do anything. Okay? So then, for the restrictions on the domain, I'm going to take this factored form, x plus 3 times x minus 3, and that cannot equal 0. So x cannot equal what? Negative 3 and positive 3. So now I've got two restrictions instead of just one. So I'm going to solve for my x-intercept. I'm going to set my numerator equal to 0. I'm going to do my x minus 4 times x plus 2 equal to 0. So that's going to tell me x equals 4 and x equals negative 2. But I'm not going to box that in because my x-intercepts and my y-intercepts are ordered pairs. So that's going to be 4, 0 and negative 2, 0. Y'all good with that? Okay, when I solve for my y-intercept, I like to plug it into my original because I know everywhere there's an x, that's going to go away. So it's more visual for me than plugging it in here. Either way, you're going to get the right answer. Okay, so I'm going to take x equals 0, and I'm going to have 0 squared minus 2 times 0 minus 8 over 0 squared minus 9. Well, that's going to leave me with negative 8 over negative 9, which is just a positive 8 over 9. So my y-intercept is going to be 0, 8 over 9. If you wanted to express that as a decimal, that's fine. Or you can do it as a fraction. So then I'm going to do my vertical asymptote. My restrictions were negative 3 and 3. So that tells me my vertical asymptotes are x equals negative 3 and x equals 3. My horizontal asymptote, the degree of my numerator is what? 2. The degree of my denominator is also 2. So this is when I take the coefficients of my numerator and denominator. So if my numerator is just x squared, that leading coefficient is 1. The leading coefficient for my denominator is also 1. So if I'm doing a ratio of 1 over 1, my horizontal asymptote is y equals 1. Y'all good with that? So then I'm going to check, does it cross the horizontal asymptote. So we set our original function, x squared minus 2x minus 8 over x squared minus 9 equals 1.
Sorry to interrupt. Oh, they're the same. Do you like this kind? If not, I can go get you a different
No,
kind.
this is perfect.
Are you sure?
Thank you.
I'm sorry.
No, thank you.
Thank you for everything.
So then, to solve this, I'm going to multiply both sides by x squared minus 9. Some of y'all are going to need to put the parentheses around that, because if this were a 2 or a 3, you have to understand that you are distributing to both terms in parentheses, not just the first one. I'm seeing that happen, so make sure you understand that. So here, my next step, x squared minus 2x minus 8 is equal to x squared minus 9. Alright, if I'm going to solve that, I would subtract x squared. If I were to do that, it would cancel. I've got negative 2x. Well, I could add this 8 in the same step. Negative 9 plus 8 is negative 1. To solve for x, divide by negative 2, x equals positive 1/2. So here I got an actual x value. So what this means is it crosses your horizontal asymptote at x equals 1/2. But I want to know what point. Well, you take that 1/2, and then your y value is the horizontal asymptote. That is where it crosses. So my y value is 1. So it crosses at 1/2, 1. You understand that? Do we have questions? Okay. So I'm going to graph my asymptotes. So my two vertical asymptotes, cut that into 3 separate parts, okay? And then we also know that it's going to cross at 1/2, 1. So I'm going to go ahead and plot that point. I don't have half points in my table in the calculator. You can change it for it to pop up, but I already know it's going to cross, so I'm going to put the point. Go to your calculator. I'm going to type my original function. And that's what the graph is going to look like. Okay? So for your table, I'm going to go as far left as I can. So the very edge of my graph is 8, negative 8. So I'm going to just do negative 6, and that gives me 1.5. Negative 5 will give me 1.7. Negative 4 will give me 2.3. Negative 3 is going to be undefined because that's an asymptote. Negative 2, 0. Negative 1, 0.6. 0, 0.9, which that's my y-intercept. Then it jumps to 1, but I know that it's going to cross at this 1/2, 1. If you want to include it in your table, you can. You don't have to. If you get carried away doing your table, as long as it actually is there in your work and on the graph, then I'm okay. Okay? 1, 1.1, 2, 1.6. 3 should be undefined. 4, 0. 5, 0.4. 6, 0.6. Everything starts leveling out at this point. I'm just going to stop there. If you look at your points between your two asymptotes, so in the middle section, it looks like it's making a straight line. Okay? This is where your graphing calculator is going to come in handy. You should know that it's going to come up and then it just curves. It really does look like a straight line there. It's just curving up and then going. So do your best to make it look like that. That's what the graph looks like. So for my domain, I've got 3 different sections. Okay? So I'm going to have multiple breaks. I'm going to go from negative infinity to negative 3. Then it's going to go from negative 3 to positive 3, and then it's going to go to positive 3 to infinity. Now what about my range? What is my range going to be? It's going to be negative infinity to positive infinity. Why? Yeah, because the middle section crosses that horizontal asymptote. So typically we break at the asymptote, but it crosses it. So this goes all the way, every single y value would be hit there. Okay, so my range is going to be negative infinity to positive infinity. Okay, y'all good with that? All right, we're skipping example 4 for time. But we are doing example 5.
I've run out of lead.
So for the first example, the first part, you're going to factor. So f of x is going to equal, if I'm factoring my numerator, x squared minus 3x. I'm going to factor out an x as a GCF. Leaves me with x times x minus 3. And then my denominator is a trinomial that I can factor, and it's going to factor into x minus 3 times x plus 1. Can I simplify and reduce that? Yes, my factors x minus 3 can cancel, so my factored form of it is just x over x plus 1. Okay? Now, when I do my restrictions on the domain, I know from this, x cannot equal what? -1. But I have to also consider what I took out. X cannot equal 3. Now, what is that x equals 3? Y'all remember what it's called from last class? That's my point of discontinuity. So, if you have two factors that can cancel out, that is now going to be your point of discontinuity. So once you do your restrictions, we're going to figure out what is that point. So what you're going to do is you're going to take this value and plug it into your reduced form. So I'm going to have 3 over 3 plus 1, which is 3/4. So my point of discontinuity is 3/4. Now what's important about that? Well, if I were to plug a 3 in the numerator, in my original numerator, I'd have 3 squared minus 3 times 3. That's 9 minus 9, which is also 0. So if your point of discontinuity also causes a 0 in the numerator, that's considered a removable point of discontinuity. I'm not going to ask you that on the quiz or test, but that's just something for you to know, okay? Now, this point of discontinuity tells me what's going to happen on my graph. That's going to be a hole in my graph. So at 3/4, I'm going to go ahead and draw my open hole. Y'all remember that from last class?
No, I don't.
So I'm able to cross this out so it's no longer there, but because there's a restriction in my domain, that is a value that that function cannot equal because it would cause 0 in the denominator. But because you can reduce it and pull it out, that's called a removable point of discontinuity. So that just means, so my graph is no longer going to be continuous at that point. So there's going to be an open circle there to state it cannot be there. It's no longer, so what we've been doing is whatever our restriction is a vertical asymptote. It's no longer a vertical asymptote because that's what canceled out and it gives me a point of discontinuity. So whatever cancels out is your point of discontinuity.
So it just skips over that point?
Yeah, it's going to be undefined in your table. It can't equal that. So then that's going to lead me to my x-intercept. Numerator equal to 0. I'm going to do my factored simplified form. So x equals 0. So that tells me my ordered pair is 0, 0. So my y-intercept is where I do x equals 0. So I've got 0 over 0 plus 1. Or I could have done it in my original. So I'm going to do both to show you get the same thing either way. So here, that gives me 0. If I plugged it into my original, I'd have 0 squared minus 3 times 0 all over 0 squared minus 2 times 0 minus 3 gives me 0 over negative 3, which is also 0. Okay? So here, my y-intercept is the same as my x-intercept, 0, 0. So my vertical asymptote is going to be x equals negative 1. It is not going to be x equals 3 because that's a point of discontinuity. So my horizontal asymptote, I look at my exponents of my numerator and denominator. The degree of my numerator is 2. The degree of my denominator is also 2. So I take the ratio of the leading coefficients. So what's my horizontal asymptote going to be?
1.
Yep, I've got 1 over 1, so y is equal to 1. So we're going to figure out, does it cross the horizontal asymptote? Well, I'm going to take my original x squared minus 3x over x squared minus 2x minus 3 and set that equal to my horizontal asymptote of 1. Multiply both sides by the denominator, and that gives me x squared minus 3x equals x squared minus 2x minus 3. It's just itself because that is a 1. Again, if it were a 2 or any other number, you're going to have to distribute it all the way through. Okay, if I were to subtract my x squared, they would cancel. I'm going to add my 2x. And that gives me negative x equals negative 3. So that tells me x equals 3. So you have to really actually pay attention to what you're doing here, because this is telling me that it crosses the horizontal asymptote at x equals 3. But what happens at x equals 3?
There is no.
There's a point of discontinuity. So x actually at 3 cannot cross the horizontal asymptote. So there's going to be no crossing. Because 3 3/4 is a hole in the graph. Y'all understand that? Okay. So this is where you can't just start boxing things just because you got an answer. Okay? Alright, I'm going to graph. Those are my asymptotes, and I'm going to go to my calculator to get my table. So I could do -5, 1.25, -4, 1.3, -3, 1.5, -2, 2, Negative 1 should be undefined. 0, 0, that's my x and y intercept. 1, 0.5. 2, 0.7, if I rounded that. So here, 3 is undefined. Four, 0.8. And it all starts getting closer and closer to 1. So I'm going to stop. If you wanted to do, say, 7, 0.9, you can. Y'all good with that graph? Okay, so my domain is going to go from negative infinity to negative 1. Then negative 1 where? Am I going from negative 1 to infinity?
No.
I have that point of discontinuity, so it's going to have to be at 3. Then 3 to infinity. My range is going to go from negative infinity to 1. Then 1 to positive infinity. But is that right? Y'all just want to write everything I write down. Is that right?
Oh, no, because
No.
it doesn't touch yours, 3.
Because of 3/4. You have a removable point of discontinuity. See, y'all just write everything I say. You gotta, I'm doing that so you catch yourself on the worksheet. So I'm going from 3/4 to 1, 1 to infinity. Okay? So, the question, how can you graph this without an Inspire at home? You have phones, right? Okay. If you have an iPhone, there's the app Calculate 84. Do y'all know about that app? Okay, so does anybody not have an iPhone? Okay, those of you with Android, you can look in your Play Store and you can search for a graphing calculator. There's one very similar. I just don't know what it's called. Okay, but I would write this stuff down and this portion of the notes so that you know how to use this. So Calculate 84 is the name of the app. It's a pink icon. And it's the TI-84. Okay? So how do you plug in the function? Well, you go to y equals in the top left. Alright. Y equals, to get a fraction, this is what I would write down. Hit alpha, and then the button right next to it. You see how in green it's frac? That's for fraction. So alpha, the button right next to it. Okay? Your X is the button you just pressed. It has an X on it. And then to do squared would be the X squared button. But if it's X cubed, you would have X, and then the little rooftop button is above the division to bring it to an exponent if you needed a higher degree than squared. Okay? So to show you how I would do this, I'm going to do that button, and then I'm going to have X squared minus 3X over X squared minus 2X minus 3. The top right, it says graph. So the graph is going to look like. Okay? To get to my table, you see table in blue. So I'm going to hit the blue button, second graph. There's my table. Where our Inspire says undefined, the 84 says error. Okay? Same thing. Okay? That's how you will do your homework. Or you could go to Desmos or any other graphing calculator online, Google one, and it will do all the same stuff. But this is super handy. You can do anything that our calculator can do. Okay? So those of you who have Android, just search in your little app store for a graphing calculator. Okay? Yeah. We're not going to have a quiz over this because the lesson next class is going to be very lengthy. And that's where everyone starts messing up. So that's just an FYI. That's why we don't have a quiz. Okay?
So where are you next Sunday?